Hello everyone and welcome to today's Osmine webinar. My name is Sam Sakasiris and I'm the National Membership Team Leader here at Osmine, and I'm pleased to be your host today. Before we start, I'd like to acknowledge the traditional custodians of the various lands on which we all work today and the Aboriginal and Torres Strait Islander people attending in this webinar. I'd like to pay my respect to their elders past, present and emerging, and extend that to all leaders of all cultures and backgrounds in our multicultural nation. For today's webinar, I'm joined by Asghar Khan, Global Head of Solution Management Nokia, to discuss Nokia's private wireless enabling pit-to-port digitalisation. Following the presentation, there will be an opportunity for audience Q&A. Please use the Q&A button at the bottom of your screen to send through your questions at any time. You can also upvote on those other audience questions that you most want answered, and then I'll take that Q&A session at the end of the presentation. So without further ado, I'd like to now hand over to Asghar to begin the presentation.
Thanks, Sam, for the nice introduction. And hello, everyone, and welcome to Pit-to-Port Digitalization webinar. And I'm thrilled to have you all with us. And in today's webinar, we will be exploring how Pit-to-Port digitalization has the potential to unlock several business benefits, like increasing operational efficiency, reducing cost, and the most important is to improve logistic planning, which is increasingly important in ever-changing landscape. Now, whatever is your objective, whether you want to improve your mine productivity or you want to make your mining operation more sustainable, I hope you will find some valuable insight from today's session, which you can use in your digital transformation journey. Now, before we dive into our session, I will encourage you to engage with us. Use the chat function to express your thought or ask any question. And we are going to have, of course, as Sam mentioned, we're going to have a Q&A session at the end of presentation. So let's get started. So in today's session, we'll start with exact summary, where we'll understand what is pit-to-port digitalization, how it can be enabled, and why it is needed. Then we will review some of the business and mission-critical use cases, which is enabled to solve business and mission-critical problem. Then we will review Nokia's connected digital mine solution and train-to-ground solution, and we'll understand how the solution can help achieve this digital transformation journey. Then we'll review a customer case study where we have deployed a pit-to-port solution, and we'll understand what benefit they are receiving after this deployment. Then we'll have Q&A session, and we'll wrap up with key takeaways. So let's get started. So what is mining transportation? So mining transportation is the process of transporting mined material from pit to a designated port for further processing or for export. Digitalization and why it's needed. Digitalization of mining processes has several benefits, like it's enable real-time tracking and monitoring of mining transport operation, providing real-time insight and valuable insights, which help mining customer take important decisions. How it's done, basically the various advanced technologies like Internet of Things, artificial intelligence, and autonomy help in streamlining the processes, reduce downtime, and improve logistic planning. The various benefit of pit-to-port digitalization, like it helps in improving supply chain management, reduce cost, fewer downtimes, and the most important thing is the greater customer satisfaction. Now, how we can enable pit-to-port transportation digitalization? So digitalization starts with identifying use cases that specifically address the operator's most significant challenges or problem. And in our next slide, we'll see how Nokia's 4G and 5G technology can enable mission and business critical use cases. So in this slide, you will see pit-to-port use cases. Now, pit-to-port use cases can be classified into three categories. Number one, autonomy. Number two, worker safety. And number three is sustainable mining. So let's start with autonomy. All the mining customers are pursuing the strategy of extreme autonomy, which means all the manual equipment and machineries like diggers, haulers, excavators, and train will eventually be replaced by the autonomous counterpart. All the mining customers we are engaged with are planning to have remote operations center and autonomy as the key use cases for the digital transformation journey. And we know that because we have done various autonomous projects for the mining customer, and we have seen the benefit they're getting out of it, return on investment they're getting it. In the safety, it has improved worker safety and sustainability. So this is one of the number one use cases why customer goes for digital transformation project. Number two is worker safety. Worker safety, of course, is very important for all the mining customer. The objective is to have a 360-degree view of people, asset, plant, and environmental condition. The most important thing for saving life, but also to reduce productivity losses and to improve operational efficiency. Nowadays, mining customer has access to various innovation, which is known as situational awareness. And this can be achieved by various technology, like Internet of Things, wearables, video, drone, and real-time data analytics. With the help of all this, mining customer can have the real-time view of the people, asset, and the environmental condition. Some of the example we can give on this site is a digital PPE, which can be smart helmet or high-vis jacket, which has a LTE chip, which is connected back to remote operation center, which give a real-time view and environmental condition and location of the worker. The next important use cases which can enable worker safety is industrial location tracking and positioning, which gives location of assets and people, instant communication like Nokia team comms, which has various features like instant push to talk, man down, and there are various other applications like Nokia drone and other technology which can help in enabling worker safety use cases. The third category of use cases which are very important for all the mining customer is sustainable mining, how we can enable and how we can reduce the consumption. And this is number one KPI for all the mining executive. Now, how this can be achieved? A low power IoT sensor can provide miners the environmental data, which can improve the air quality, lower the power consumption by enabling a ventilation on demand. Similarly, low power IoT sensor can also reduce the water consumption, mitigate the pollution risk, and also manage tailing dams and ponds during the inclement weather. Other example of sustainability can be low power IoT sensors embedded in the plant and machinery, like trucks, which helps provide real-time data and condition of the assets, which help remote operations center make a planned decisions for the maintenance. Now, for example, unscheduled maintenance can cause havoc in any mining operation. So if you have a data of wear and tear of the assets, a condition of the asset, you can do planned maintenance. Now, some of the spare parts, what we understand is can take up to 5 to 6 months. So if you have some unplanned maintenance and you don't have spare parts, it can interrupt your mining operation for a long time. So this kind of enable use cases and getting real-time data can really improve the overall life of the assets, can improve more planned maintenance, reduce power consumption, and in turn can make the mining operation more sustainable and green. So these are some of the use cases. There are many use cases, but we have picked a few use cases which help in enabling pit-to-port digitalization. And in our next slide, we will see how Nokia technology can help in enabling this mission and business critical use cases. So in this slide, you will see Nokia N2N Architecture. It is a high-level overview. Now, Nokia is a market leader as per Gartner and various other research organizations. We are Nokia is market leader in private wireless networking. So we start from left to right here. On the left, you see a typical open pit mine, and then you see some trucks and excavator at the mine site. So how we enable the autonomous mining is all these trucks and excavator has chip installed in them with the LTE user equipment, which is connected to the shell tower or with the radio network, which helps truck upload all the data, and with the help of remote operation center and other autonomous application software, it enables autonomous mining in the open pit mine area. Now this radio network is controlled and managed by packet core. Packet core network can be installed at the mine site, or Nokia can also offer a cloud-based solution. So this is typical a high-level overview of private wireless network. Now we are taking our solution to beyond connectivity with the help of MX Industrial Edge. So MX Industrial Edge, which you see on the center of the slide, it is basically enterprises central orchestration, single pane glass management, which unify all the operation traffic application in one single platform. And all the data is stored at premises for added security. And MX Industrial Edge is designed for low latency and is redundant and robust edge network, edge router. So, and how it works is we can onboard all the application, whether Nokia or third-party application at the MX Industrial Edge. For example, you see 360-degree audio and video. So Nokia has an application by the name Real-Time Extended Real-Time Multimedia, which is known as RXRM, which optimize the video bandwidth by 90%. And it has various other features. This application, then there are other applications like Nokia Industrial Location Tracking, Nokia Team Comms. All this application can be onboarded into single MX Industrial Edge platform. And then there are third-party applications like Guard Hat. And in the future, we're talking about maybe all this ecosystem partners, autonomous application can also be onboarded in MX Industrial Edge. Right now we have close to 50 application onboarded in MX, and we're going to have many more in the near future. What you see on the right, further right, is our train to ground solution, which is specifically designed for a rail network. And we will talk about more that particular architecture in the next few slides. So with the help of private wireless network, beyond connectivity, and train to ground solution, Nokia can enable pit-to-port digitalization for any mining customer. Train to ground solution. So train to ground solution has Nokia core network and trackside equipment, which is primarily a radio network, which is part of connected digital mine. But there are some unique application which are tailor-made for a rail network, which is Fleet Network Manager and MX Boost for train to ground. And we'll discuss about that in our next few slides. So MX Boost. So MX Boost is basically multi-part connectivity. So what it does is basically it is a capacity aggregation across all the backholdings, and it assured bandwidth for data-heavy application. So for example, in the pit-to-port network, which is very long from mine to port, can be 1,000-kilometer network. So MX Boost can help aggregate LTE bandwidth, Wi-Fi coverage where you have in the patch of the somewhere in the mine site, and also satellite network, and can give you one thick pipe for data-heavy application. And it is basically automatic rule-based routing across multiple technology. It is very smooth handover from one technology to another technology. There's no packet loss. And the most important thing is it has been designed for high-speed mobility, and it is safe, secure, and is end-to-end encrypted. Another important feature of MX Boost is basically it makes the network more redundant. For example, a rail network can go across thousands of kilometers due to inclement weather, and because let's say, for example, a lightning strikes fuse cell tower, and there is no radio LTE coverage in 30 or 40-kilometer patch of the rail network. Then what happens when the train is passing through that area where there is no LTE coverage, it will switch over from LTE to satellite communication without interrupting any critical application. And this is one of the most important features of MX Boost. And it has been designed, this particular MX Boost has been designed for train to ground. The next important application which we have for our rail network is Nokia Fleet Network Manager. Nokia Fleet Network Manager gives you real-time view of the train, its location, speed, payload, RF signal, etc. So it helps you providing the complete picture in one dashboard. It can help you on configuring, troubleshooting the network, and all other features which is done by NMS. Plus, it has API, and it can also enable an onboard third-party application to manage everything on the one network, which is Fleet Network Manager. Now, this particular application has been deployed in various metro network across the globe. Even in Australia, this has been deployed. So this is very commonly used application in the train. So with the combination of connected digital mine solution, beyond connectivity solution, and train to ground solution, Nokia can enable pit to port digitalization process for the mining customer. So we will now go through the case study of one of the mining customer where we have deployed this pit to port digitalization solution. So this customer is based in Latin America. It is one of the largest mining customer in Latin America. They have around 10 mines, and all the 10 mines are connected by a rail network. And the pit to port rail network is more than 1,000 kilometers, connecting various mines from pit to port. Before they transform their whole network from analog to digitalization with the help of Nokia, what challenge they were facing? So basically, they were unable to manage rail infrastructure. It was basically inefficiently managed because they were not having the complete view of the network, the assets were underutilized, and the cost of operation was very high. The next important challenges they were facing was suboptimal asset management. As we have discussed earlier, how LTE network with the help of modern applications like intelligent IoT sensors and artificial intelligence can help plan maintenance and reduce unplanned breakdown and extend the life of asset. So this was not possible for them in the old network. The lack of visibility and collaboration. They were having 3 different networks. They were having one network for the mine. They were having second network for the train, which was some VHF and UHF, and the third network was for the port. So they don't have a complete one single view of end-to-end pit to port network, which was not helping them take valuable, important decisions. Data decision was not taken on the basis of any real-time information. It was more reactive and it was delay. So this was impacting and increasing the cost of their operation. The next challenges they were facing is because of unplanned maintenance, unscheduled breakdown, high energy consumption. The operation was not environmental and sustainable. And that was one of the concern because every customer, and specifically mining customer, wants to make their operation more environmental friendly and sustainable and possible. And in the next few slides, we will see how Nokia has helped them overcome these challenges and how this digital transformation journey has improved their productivity, reduced losses, make their operation more sustainable, and has improved worker safety. I'll move to next slide. Okay, I think I clicked twice. So the digitalization journey. So they were using various analog technology and various other applications. So they partnered with Nokia to establish the private wireless network. The first phase was at the mine site. We deployed our private wireless network at all the mine site. All the mines were connected. Customer was happy with the outcome of deployment in the mine site. And then we moved to, we have extended this network from mine to port via train network. So we provided coverage all across the track till the port. And the journey, this digitalization journey has helped them optimize the transport routes, predict equipment failure, improve overall operational efficiency and sustainability. And we will see in the next few slides what are the benefits they have got. I'm to say all this contribution they made in the digital investment, what return on investment they're getting in reducing the cost, improving the efficiency, and reducing the greenhouse gas emission. So let's have a look and review on the improvement they have made after this digital transformation journey. It is quite encouraging actually. So the first one, economic and environmental impact you see is after implementing a digitalization project with the help of Nokia, it helped them in real-time performance monitoring and control of the whole pit-to-port network, which helped them in understanding the speed of a train, where the train is, location of train, payload, how much load the train is carrying, fuel consumption. And all this information helped them in improving the efficiency. And we can see this led to the following improvement. The 18% increase in the daily rail traffic. And this report has been published by the company in the 2022 production and sales report. So this is a public report. So when we say 18% increase in daily rail traffic, I'm going to say the best example I can give is if they were having 5 pit-to-port run in 1 week, they have increased that run from 5 to 6 in a week. I'm just giving example, which means they have improved the train run almost by 20%, which means they were able to export more iron ore or whatever they were exporting, copper, compared to before. Then what was the next improvement they have? 30% reduction in travel time for train. Now this is another significant improvement because of the complete holistic view of from pit to port. They were able to reduce the train time by almost 30%, which means if train took 10 hours to reach from pit to port, they were able to reduce the time by 7 hours. Okay, that's another significant improvement. The next is asset management and maintenance. Now, this is very important. The asset utilization is one of the most and serious problem for all the industry, not just mining. I'm going to say the company has implemented predictive maintenance by having various sensors and artificial intelligent application deployed, and they were able to monitor and analyze the condition of assets in real time, which helped them in planning schedule maintenance, and understanding the status of the assets, which helped them 25% reduction in unplanned downtime for the rail assets. So the rail were not in the workshop. The train was running more on the track, carrying iron ore, instead of spending 25% time in the workshop, which was in the earlier. So all this improvement in information has helped this reduction of 25%. Now, how this has translated in the dollar value, which is very important. So because of all this improvement, they were able to make a saving of $80 million in annual savings due to reduced maintenance cost and increase assets lifespan. Now, this is a significant improvement. 80 million annual saving. This saving can be used for other improvement project or can be invested in other area of the business. Very encouraging and significant improvement. So let's have a look at some other improvement what was made. So port operation optimization. So mine, of course, was improved. Train, they managed to reduce the downtime, and they were able to increase the downtime 25%, 80 million saving. What was the improvement in port? With the complete end-to-end digital network, they were able to introduce automation at the port, and they were able to have a better control at the port level. They were able to load and unload the ore at faster rate than what they were doing earlier. And the following are the result of this digital project according to their 2022 operations report. They're able to increase the port throughput capacity by 15%. So they were able to export more ore compared to what they were doing earlier. So how this has translated in dollar value? This has helped them 50 million increase in annual savings. So they have saving of 50 million in annual saving from reduced vessel turnaround time and the demurrage cost. So overall, another substantial saving, 80 million and 50 million, altogether 130 million from train to just port operation. Environmental impact and reduction. Now, sustainable is very important. This is important for all the industry, but it comes to mining. Everybody looks at mining with a different lens. It is very important to be more efficient and have a lower greenhouse gas emission. So with this information, digital transformation, using modern technology and having real-time view and better utilization of assets, making the assets more energy efficient, they were able to make a reduction of 12% in the greenhouse gas emission from the transportation operation. Now, this is another important big tick in the box. I will say this is one of the biggest tick in the box, because this is something which company get rated nowadays, The next is 8% reduction in energy consumption for transportation operation. So you have better visibility of truck. You know if truck is running on this particular track, if it's consuming this fuel, and what are the reason for this fuel consumption can be optimized by changing some track or making better road or whatever, a tire pressure, etc. This all help in reducing the energy consumption. So another significant improvement in port operation and environmental impact reduction. So finally, what was overall improvement? I mean to say this is something very important to have a look at it. So before we go there in the overall financial impact, we'll have one more review of port operation optimization. As I mentioned earlier, company was having 3 different network. Mining was separate, train was separate network, and port was separate. There was 3 different team managing 3 different network. There was no common information sharing and no common decision-making ability. There was no data-driven decision. So with the help of this digital transformation project, the company has set up a central transportation control center that monitor and coordinates all transport activity. So look, even the truck running in the pit is also a transport. So everything, I mean to say, right from truck, pit to the port, everything was managed by the transportation control center. And this has helped them in 10% reduction in lead times for iron ore delivery. Now, this is another important, which means if they were taking 10 days to deliver iron ore from pit to the customer site, for example, they were able to do that in 9 days. So that's another big tick in the box. Customer is satisfied. He's getting the ore on much earlier than what they were getting in the past. Overall financial impact, as per the report, 200 million cost reduction per year operation. Now, this is just a cost reduction. If you also consider other factors like they are able to export more ore, the lead time has gone down, their 18% capacity has increased. The company of this size will have benefit of $500 million additional revenue over and above this 200 million cost reduction. Now, another important thing is 18% increase in productivity, optimizing truck, train, port, and inventories. They were able to increase the productivity by 18%, which is quite a significant number for the company of this size. And this can be 18% is big number for anyone. So overall, very good number. And digitalization is a journey. There's just a 1-year-old report. You keep on improving. Once you have information is the power, right? You can use it to improve your processes. So this is continuous improvement. We are at Industry 4. Very soon we'll be Industry 5, and I will say Industry 5 is almost there now. So we are talking about getting ready to harness and harvest that benefit of Industry 5 as well, right? So this is continuous improvement, and we'll see this further improvement year on year. Okay, so what are the key takeaways? I mean to say, very important, encouraging result, case study where we review our solution. So there is a strong drive towards pit-to-port digitalization. We are seeing that across the globe. All the customers who has a real network, or whether they have a real road network, they still wants to optimize their transportation. So there is a strong drive towards pit-to-port digitalization in open pit and underground mine. And Nokia is in pole position because we have delivered over 80 projects across the globe. So we have a very vast experience of deploying our network at a mine site. We have a world-leading knowledge, technology, and pre-validated solution to make this experience available globally through mining segment solution. The most important thing is pre-validated solution. Nokia solution is not just validated by Nokia in their lab, but this solution has been validated by the ecosystem partners like Komatsu, Caterpillar, Sandvik. Even in transport, Nokia is a market leader in a train network, private wireless. Our Nokia solution has been tested with Hitachi, Alstom, various other rail network, and we have deployed our solution in various parts of the world. In Australia also, we have a very big market share. And 4G and 5G technology, number 3 takeaways, can unlock future mining potential by enabling mission and business critical use cases. As I was saying, we are Industry 4 now, almost Industry 5's year, where human and machine will work together. We'll see more robotic and more digital operation in Industry 5. And 4G and 5G technology has the capacity and a bandwidth to enable all this mission and business critical use cases. With this, I finished my presentation, and then now we'll hand over to Sam to, if we have any Q&A session, if there's a question we can answer now. Over to you, Sam. Thank you.
Fantastic. Excellent presentation. Thank you, Asghar. Yeah, it's now time for Q&A. You can use the Q&A button at the bottom of the screen to send for any questions you would like answered, and I'll get started on those now. The first one is, you gave us a lot of ROI based upon a project mentioned in a 2022 report. Given this is open, can you please let us know where to find it? That is, which company these results are with?
Sure, that's a very important question. Let me get back to you on this. The company was not Yeah, sure. I will get back to you with the company name. Okay, so I will leave it with me. I will talk to my commercial organization and I'll get back to you if I can share the name of the company. But this is a published
No worries.
product. Yeah.
Thanks. Another question we have, how do you design your overall solution for a given mine? What inputs do you need? How can we understand coverage?
Yeah, sure. I think it's very important. Every mine is different. So of course, what we need is basically we can have early works where we start from the scratch, where we go and we create a digital network, digital design for the customer. Or other option is where mine customer already has their digital map they can share with us. And on that basis, we can do RF design. The most important thing is what are the applications they're going to run? Are they going to run autonomous haulage, and they want video stream? What are the other applications they're going to run? On that basis, we can design the network. And what is the uplink requirement? What is the latency requirement? All this criteria drive the RF network planning. We have a very strong RF knowledge team, which has experience of more than 80 networks designed. So yes, we can do right from early study to whatever stage of the project you are. We can help you with your RF design for the mine site. Yeah, both for open pit and underground. Yeah.
Thank you. Next question. What are the challenges of deploying pit-to-port digitalisation solutions, and how is it different than deploying LTE solutions in the mine site?
Yeah, that's very important. Yeah, very interesting question. So pit-to-port, when we're talking about the three different area of operation: mine pit, train, and port. And in this, that three different culture, right? We're talking about mine organization, we're talking about train, and then port. So there's a three different culture. We're talking about port, which is different. There's some different government regulation, different requirement for the train, and different for pit. And that also different data requirement. As I mentioned, when you do RF design for mine, your uplink requirement, downlink requirement, latency is different. When you do design for train, it has a different safety requirement. You have to understand that. Now, train is a very wide network, 1,000 kilometer. It can go up to 600 kilometer, 1,000 kilometer. So you have to consider various backup link, backup plan to make sure that there is a smooth handover. When you go to port, sometimes the port authority have their own network. So we have to integrate our private network with the port network, with like Mokan and other design, other technology we can use. So it's basically a totally different approach. Is technology, very different technology, different ecosystem partner. Like mine can have Komatsu or Caterpillar, train will have Alstom, port will have Krona Crane or different crane provider. So you have to gather all the data requirement, understand the need, and then design the network. It's a bit more different approach or holistic approach as compared to just designing a network for the mine. It's a bit complex than mine network, I will say.
Thank you, Asghar. Our next question is, what are the key technology factors that miners should consider when selecting the technology?
Yeah, I think that's very important. So the important factor is interoperability. I'm going to say with your current ecosystem, make sure that technology you select is work with your ecosystem, what you have at the mine site. Networks should be scalable, very important. You should be able to upgrade and scale the network as your organization, your mine grows. It should be reliable because you don't want any downtime at your mine site. It should be reliable. It should be secured. So all these are the important factors you need to consider when you are selecting the technology, and also get ready for the Industry 5 because there will be many more use cases, many more stringent requirements. So whatever technology you select now should be a future-proof.
Thank you. Next question. What services can Nokia offer for pit-to-port digitalization solution deployment?
Yes, as we can start with, of course, consulting we can offer. We can do consulting. We can offer the whole network infrastructure design. So Nokia is not just RF company. As we discussed, we have RF, we have a network infrastructure. We can provide switcher routers. We have application hosting platform like MX Edge. We also have application. We also have IoT. So we can provide complete end-to-end solution. And plus, we also have a managed services. We have training. So Nokia can provide you a complete turnkey end-to-end solution and services for enabling your digital transformation journey.
Thank you. Obviously, Nokia has competitors in Australia, but what's the differentiating factor for Nokia specifically in Australia?
Yeah, that's very important. So look, the most important thing is we have a strong presence in Australia. And Australia is the place where we started our mining journey. So 10 years back, we deployed our first network at Rio Tinto, if my memory serves, in 2014. So we have a very strong knowledge. We know the Australian mine very well. We have teams spread across Brisbane, WA, and everywhere Adelaide to serve the mine site. And our team is very experienced. Most of the people working in Nokia are for the last 15, 20 years on average. So we have an experienced team and with the experience of Australian mine site.
Okay. With the port-to-pit digital solution, are we designing it using a single core, or do we have to have a geo-redundant core?
It can work with a single core, no doubt, but highly recommended geo-redundant core. We always recommend for this kind of critical network to go with the geo-redundant core. So the solution we presented, the use case we presented was geo-redundant core. And most of the mining deployment we have in Australia is geo-redundant core.
Thank you very much. That looks like the end of the questions. So in that regard, I'd like to give you a big thank to Asghar for sharing his expertise today. We have recorded this webinar and it will be available for your on-demand viewing, as well as being available on Osmine's YouTube page. We will send out the link to everybody who's attended. If you have any further questions for the presenters, please contact us and we will put you in touch with them directly. Thank you to everybody who's attended, and we look forward to welcoming you to the next Osmine webinar. Enjoy the rest of your day. Thank you.
Thanks, everyone. Thanks for joining. Thank you very much.